Hello. In this example, we'll learn how to use the epsilon delta definition of a limit with quadratics. Right. So our first step is our work, right, to get delta in terms of epsilon. So again, we're going to use our f of x, so x squared plus x minus 1, minus our limit, 5. And again, we want to get it so we have our x minus a, which in this case is x minus 2. So we get x squared plus x minus 6, which can factor x plus 3, x minus 2. We get x plus 3, x minus 2, which is less than x plus 3 times delta, right? Because we replace our x minus 2 in delta. And again, this is what we want our epsilon to be. X plus 3 times delta is equal to epsilon. And again, we remember from class, since x is allowed to vary, right? That's the whole point of a limit. X is being allowed to vary to a value. I want to find some value c such that this value of x plus 3 is always going to be less than c. So we pick a delta being equal to 1, right, temporarily. So that will get x minus 2 is less than, now instead of delta, we say it's less than 1. So we can have our bound of x minus 2 is less than 1. And we want to get to x plus 3. How can we get from minus 2 to plus 3? We'll add 5 to everything. So we'll get 4 and 6. So when we look for an absolute value of x plus 3, I'm going to look at the absolute value of 4, the absolute value of 6, and say which of these has a bigger absolute value. And of course, that's going to be 6. This is what our value of c is, right? Our 6. So we'll actually get up here, right, that c times delta. So delta is equal to epsilon over 6 in that case. But because we have the two values of delta, we don't want delta actually to be equal to any one value. We want it to be the minimum of 1 in epsilon over 6. And now we can move on to the proof. Given epsilon greater than 0, choose delta to be the minimum, exactly what we said before, of 1 and epsilon over 6. So when 0 is less than x minus 2 is less than delta x squared minus or plus x, right? Minus 1 minus 5, right? Our f of x and our L is equal to, again, that same inequality as before. Minus 6, this is x plus 3, x minus 2, right? Which is equal to, we can get that absolute, we can distribute that absolute value, which is equal to, again, x minus 3 is less than 6 we found, and that's less than delta. And we said delta is, since it's the minimum, delta is either going to be equal to epsilon over 6 or less than epsilon over 6. And since we don't know, we have to use this less than or equal to, which is equal to epsilon. Oh, sorry, that's a 6. And so as we can see, we have our system of inequalities and equalities that makes f of x minus L less than epsilon. Hopefully this is helpful, and I'll see you in class.